So without further ado, I'm going to go ahead and hand it over to Parag, and he'll kick us off.
Thank you, Kevin. Welcome, everybody. Kevin, just to confirm, is the audio still good?
Yes, I can definitely hear you loud and clear.
All right, great. Thank you very much. All right, everyone, welcome to today's webinar. This topic is very dear to me, networking foundations, partly because, in some of the more advanced classes I teach that I've taught in the past as well, we get students who don't have this foundational knowledge, and then, of course, it's hard for them to progress and learn what we are teaching in more advanced classes. And in general, I'll talk about why this information is so vital, so critical to all our development and our ability to also do our jobs well. So why this? So today's agenda is, why is this information so important? We'll talk about the basics of the OSI model. We'll talk about and the basics of not only the OSI model but switching, routing, and I'll give you a brief overview of TCP/IP and subnetting, kind of a sneak preview really, and then we'll have time for Q&A. Right? So save your questions at the end, and if you like a particular question that you see going up, then also upvote it, and it'll get bumped to the top, and then get answered, in that order. Right? So thank you. All right. So why is this so critical? First thing is, today networks are everywhere. In our homes, we have networks, and of course, at work, we have networks, and we really cannot design, operate, or manage, or even troubleshoot our networks anywhere near adequately without this foundational knowledge. So this is just the basics. Now, students sometimes try to skip this and jump into the more complex things, and without a strong foundation, your structure is not going to be very stable, very strong, and the same thing applies here as well, right? So the OSI model, and by the way, and I've seen this in real life, right? We simply are not effective at troubleshooting, managing, or even designing modifications, enhancements to our networks without this knowledge. So I can't emphasize that enough, right? Okay. So the OSI model, now it's been around forever. I don't even remember how long ago it was developed, but it's such a great tool, not only for development of networking, but even for education, for our learning purposes. So it breaks the networking process into manageable pieces, if you would, or manageable units, and also helps, identify a common structure, if you would, to explain the components, functionality, and so on. So it's very important to know not only the layer names and numbers, but really a lot more about it than just that too. And we'll focus more on the lower layers here rather than the upper layers, partly because they are more involved. And when I say lower layers, I mean 1 through 4. They're more involved in moving the data from point A to point B than the upper layers are, right? So how does it all work? The way it works typically is, right? Someone sends data, and each layer adds its own header. Now, in each layer's header are instructions. Instructions for the recipient device to learn from and use to process this data and to handle it. Eventually, it's sent across the wire as ones and zeros, bits. And in the recipient's device, again, each of the respective layers' headers are processed before sending the data up until eventually the data makes it to the right process or right application, right? Because on our computers, we could be running lots of different applications, and processes, and each of them has to get their data respectively. So that's what happens. And of course, that some of the headers will also help get the data to the right device, right? Because on the internet, in the world, there are lots of devices. How do we make sure the data gets to the right device? So that's also partly covered by some of those headers. So layer 1, physical layer, right? It defines the physical specifications of how connections are made, how data is transmitted, literally what kind of electrical signal or optical signal represents a 1, what kind of signal represents 0, or even nowadays radio waves, right? Not just wired connections. It defines what kind of the physical properties of the medium, like whether it's a cable, whether it's radio waves, microwaves, right, or radio waves, or even fiber optic based connections, all of that. And then also data link layer, layer 2, handles the physical addressing, also known as MAC addresses, hardware addresses sometimes. And it also controls who has access to the media when, right, or how media is accessed by whom, and who has the right to transmit and so on. So those are the things that are handled here by the data link layer. And so physical or MAC addresses, right, hardware addresses like it's called. Network layer handles the logical addresses. Right? So example would be an IP address, and also handles the routing. Network layer handles the routing, which is basically used to get data from one network to another. And also handles prioritization, quality of service, that kind of stuff. So those are the functions associated with network layer. And I forgot to mention, but Wi-Fi, Ethernet operate at layers 1 and 2. Right? So Wi-Fi and Ethernet operate at layers 1 and 2. They are the ones that, they are the technologies that help move data within our networks internally. Right? Similarly, network layer standards, IP is the main protocol that's used at the network layer, and routers operate at the network layer as well. Right? So both of those together will help get our data from one network to another or one device to another. And transport layer, right, handles the segmentation of data. It breaks up our data into smaller chunks, if you would, and then helps send it across in streams. Also helps with the error handling and protocol or application identification. In other words, the transport layer uses something known as ports that helps identify whether the data is meant in our machines for email application or web browsing or messaging or database application or whatever else we are running. It's what distinguishes which process to send the data to. In fact, even when you're browsing, we have lots of tabs open. The transport layer helps distinguish which tab specifically to send the data to. Right, so that's what's neat about it. Examples of standards at the transport layer, TCP, UDP. Those are the main protocols used at the transport layer. So that's, again, and I won't get into the basics of layers 5, 6, 7. It's not that they're not important, but just in the interest of time, I'll stick with these for now. And then you can obviously learn more about it later on, right? Now, switching operations, right? So switching handles the transportation of local traffic. Now, what do I mean by local traffic? By local traffic, I mean traffic internal to our networks, so in our internal networks, as opposed to remote traffic. That's a distinction I want to draw between those two types of traffic. So think of, here's the analogy I like to use. The router is going to handle traffic between networks, right? Router's route, which is to get traffic from one network to another. So I like to think of it as an airline. Airlines get us from one airport to another. That could be typically from one city to another city, right? And airlines are not concerned about how we get to our final destination, right? They drop us off at the airport, and we're on our own. So that's kind of how a router operates. It drops us in the right network and then says, okay, good luck. Switches are like the Uber or the shuttle or your friend that gets you from the airport to your final destination, whether it's your home, your hotel, your friend's house, right? Whatever that may be. So that's how switching works. Well, not how it works, but that's its main purpose. And the way switches work is they have three main functions. Okay, so that's very critical for us to understand. Switches have three main functions. Number one is learning MAC addresses. They learn which MAC addresses are associated with which port of the switch. In other words, they are located off of which port. Then, after having learned MAC addresses, it can perform forwarding filtering. So it will forward only out the appropriate port that data belongs to, and filter on all the other ports. Right? So that's the other crucial piece, crucial function that switches perform. And that makes it much more efficient because now other devices won't even see that data, right? That it does not belong to them. So that's the second function, forwarding to the appropriate device, filtering from all the others. And flooding is basically when the switch does not know where the destination lives. In other words, if the switch has not learned about the MAC address of a particular device that someone has tried to send data to, so it says, okay, I don't know, so guess what I'm going to do? I'm going to flood. Now, flooding is not the same as broadcasting. They are different. Broadcasting means addressing it to everyone, saying, I don't really know who to even send it to. So everyone take a look, see if it applies to you. Flooding is still typically implying that it's sent out all ports, but it may be addressed to some specific user rather than everyone. But it could be addressed to everyone too. Broadcasts by definition are flooded, but even unknown unicasts, as it's called, when it's destined for one specific device, but the switch hasn't learned yet who it's for, or where that device lives, rather, not who it's for, but where that device lives. And so the switch will flood it, will send it out all ports, but it's still addressed just to one particular device. Right? So that's the idea of pre-switching functions. And by the way, the switch keeps the MAC address table updated. When it learns MAC addresses, it stores them in a MAC address table. And it keeps those updated. If the user moves their device from one port to another port, from one office to another office, the switch will very quickly update its MAC address table to reflect the new port that the device lives in. So it'll only keep it associated with one port, right? Each MAC address. So that's typically how it works. And notice here in this example, what they're saying is when device A sends a frame to another device, its MAC address is updated in the switch lookup table. What they call the switch lookup table is also called the switch's MAC address table. Same idea. So here device A sends a frame, right? Here device A sends a frame. Oops, sorry. Here device A sends a frame. As soon as the switch receives it, it first looks at the source address and learns from that, saying, okay, look, this source lives off of my port 2 because that's the port on which I received this frame. And it puts that in the MAC address table, saying this MAC address lives on my port 2. Then it looks at the destination address, saying, okay, do I know where the destination lives? Notice right now the switch's lookup table was empty. So it says, I don't know where it lives, so guess what I'm going to do? I'm going to flood it. Send it out all other ports, not the one it came in on. Now, send it out all other ports, and so all the other devices potentially will receive it. And the switch says, well, regardless of where it lives, hopefully you'll get it, right? So that's the idea there. Now, the other devices will ignore it because it's not their MAC address, but device C says, whoa, that is my MAC address. It was destined for device C, right? If you recall, take a look. Destination address ends in 39476 Charlie. So that's device C's MAC address. So the other devices ignore it, right? And C says, whoa, that's for me. I better open it up, look at it, and maybe even respond. So that's what device C will do eventually. And when device C does that, guess what? When C sends a reply, the switch adds C's MAC address to the table, again, based on the source, and then forwards the frame, right? So guess what it does? It receives it on port 7, so it makes a note and adds that MAC address, C's MAC address, and associates it with port 7. Saying, okay, now this MAC address lives on port 7. I've learned that. Next time this device is a destination address, or this MAC address is a destination, I'll forward it only to 7, filter everywhere else, and not flood. Right? And of course, then looks up the destination, saying, do I know where the destination of this frame lives? And the answer is sure. That's device A's MAC address, of course. The C is responding now to A, right? So it says, yeah, I know. So great. I'll only forward it out port 2 and filter everywhere else. So other devices won't even see that frame. Right? So that's the big deal of how forwarding filtering works. Now, loops in general are a huge problem in switched networks. But unfortunately, loops are a natural side effect of having redundant connections. We always want redundancy, and we cannot have redundancy without loops. Redundancy is good, loops are not. So that's kind of a problem. And so spinning tree protocol was developed. And back then, these were not even called switches. These were called bridges. Right? So back when these were called bridges, spinning tree protocol was developed to basically break these loops. Right? And the way it logically, not physically, logically it breaks the loops by putting some ports in the blocking state. And in doing so, by putting some ports in the blocking state, what it does then is effectively creates a network as if this link does not exist. There's no data is allowed in or out of that particular port. If that's what these switches have agreed on or figured out, that that's the best way to break this loop. Right? So it holds an election. One switch is called the root. All the other switches are called non-root. And then figures out, really builds a tree, so to speak. In a tree, there are no loops. And there's only one path to get from any one point of the tree to any other. So that's what it does. By breaking off loops somewhere or the other, it will create a tree-like structure in the network, and that'll help keep the network smoothly operating. Now, of course, the whole point of having these redundant connections is that if one of your primary links fails, the redundant link should be used. And so spinning tree protocol will also detect that. If one of the primary links fails, it'll remove this, or it'll change the state of this port from block to forwarding and enable this link to work, thereby giving us the benefit of that redundancy. Right? So that's the idea. And that's, like I said, we offer multiple 5-day classes on switches. So on switching, so I can talk about this all day long, but obviously we wouldn't want to do that right now, right? Now, routing is another key function of networking, right? Like I said, routing's purpose is to get our data from one network to another. Just like airlines, right? Airlines don't care how we get to our hotel or our house or our friend's house. But airlines say, look, we drop you from one city to the other with your luggage more or less in one piece, and then good luck, right? So that's kind of what routing is all about, getting us from one network to another. And in this example, we have 4 lanes, if you would, connected by some complex set of wider network connections. That's what it's trying to, indicate here. And router's job is to figure out the most efficient or the best path to get from one network to another. So they communicate with each other, right? The routers communicate with each other, and they figure out what is the best path to get from one network to another. And in doing so, right, they will construct a routing table. So the routing table basically will have the list of the best paths. Now notice each router, by the way, has multiple paths to get from one network to another, right? Each router has at least 2 minimum, ways to get from any network from itself to any other network. Some routers have 3. Notice this router has 3 connections, so it may have 3 paths to get to this network, and so on. But each router maintains a routing table with only the best path information. It may have knowledge, it would have knowledge of other paths, but only the best path information sent to the routing table. And then, when a router receives a packet for a destination, it will compare that destination to its routing table. When it compares the destination to its routing table, it says, okay, well, does my routing table have a path for this particular destination? And if the router says, yeah, sure, it does, there's 3 possibilities of what can occur when the router checks its destination, not its, but it checks the packet's destination address with its routing table. So there are 3 possibilities of what can occur. One possibility, it finds one route only that matches that destination. That makes it easy. That says, okay, well, there's only one, do what it says. Just send it out that path, and we're done. And the router forgets about that packet. Another possibility is there are no routes. Now, there are no routes. The router says, okay, well, guess what? I don't have any routes. The router is not going to bother looking for one or trying any harder. It says either I know it or I don't. Yeah, if I don't have a route to that destination, it drops the packet and then sends a message saying, sorry, that destination was unreachable to the original source. Well, whatever device was the original source of the address of that packet, sends them a message saying, sorry, I had to drop your packet because I don't know how to get there. And someone thought I would, but I don't. And that's why it was forwarded to me, right, is the implication. The third possibility is that you may have multiple routes to a destination. Now, if there's multiple routes, then it checks the longest bit match and then the lowest metric. I'll explain metric in a moment, but the longest bit match is basically the maximum number of bits of the IP address, destination address rather, matching with the corresponding route in the routing table. So that's what's used. So that tries to find the most specific or the best match, so to speak. Right? And then the lowest metric. And metric, by the way, is nothing but a way to measure how easy to reach or hard to reach a destination is. Right? If you say, hey, Parag, how far do you live from Washington, D.C.? Because I live in the Baltimore, Washington area, right? So if I give you the distance in light years, you're going to get annoyed. Or if I give you the distance in feet, you would also get annoyed. You would want the distance in miles or kilometers, something that's more logical and that makes more sense. So similarly, metrics are used by routers to identify how easy to reach or hard to reach or how far or near, so to speak, a destination network is. And so hop count is one metric. It's not very sophisticated. It just counts how many routers you have to go through. It just says nothing about the links or the quality of the links or the length of the links. Right? It could be from here to Frankfurt, from Washington, D.C. to Frankfurt and back to Los Angeles. That's just still considered one hop or two hops, right? So from D.C. you go to Frankfurt and then L.A., and that's the second hop. So well, that's not a very efficient way to get to L.A. from Washington, D.C., even though that's what hop counts might say. Bandwidth is much more sophisticated, right? Metric. And then you have others as well. Some of these are not as efficient as others, but they are sometimes used. But that's literally how routers figure out which is the best path. So in order for us to understand how the router is figuring this out, we have to have a good understanding of all this also. And so eventually, like I said, routers exchange messages with each other and figure out the various paths. But literally which metric is used will also depend on which routing protocol is used. Because different routing protocols use different metrics. And they have different ways of identifying which is the best path. So basically the idea here is that routers may either use bandwidth or hops. So if remember, if only hops are used, guess what? From LAN A to LAN B, this is the most efficient path because it has the fewest number of hops to go through. But notice this link is the least bandwidth. If bandwidth is a criteria, then the 1 gigabit per second links are the best, represent the best path to get from one network to another, right? From LAN A to LAN B. So this is really how these routers will figure out. And they use what are known as routing protocols. That's the purpose of routing protocols. Routing protocols' purpose is to help routers exchange messages and learn which is the best way to get from one network to another. And each routing protocol uses different metrics. So they have different criteria they use to evaluate what is considered the best path. Right? So if you say, hey, what's the best path to get from here to that store, for example? Well, it depends. Do you want to drive the least distance? Do you want to get there the fastest? Do you want to pay least toll? Right? So all that could be different criteria, the same way routers use different criteria as well. And so yeah, that's the gist of routing, right? But again, like I said, we teach multiple 5-day classes on routing. So, I can talk about this quite a bit. I can spend half a day to a few days on just some of these protocols individually, right? There's a lot more details, and it's pretty complex. So if your job involves managing routers, then you would want to have a very good understanding of these ideas as well, okay? In managing the routing function. TCP/IP is another foundational topic We must know, right? Because everyone and their brother is using it today, everywhere. We use it at our homes, right? In our homes, we use it. We use it at work. We use it pretty much everywhere. It's universal. That's back in the old days. A few decades ago, it wasn't the only protocol used. There were other protocols used in networks as well, maybe more than a few decades ago. But for a while now, TCP/IP has been the dominant protocol out there, right? And so this slide helps illustrate the basics of TCP/IP nicely, or at least not the basics, but how they are interconnected, right? So Ethernet Wi-Fi operates at what they call the network access layer, layers 1 and 2 of the OSI model. Internet layer, what's called the network layer in the OSI model, is the TCP/IP model they're showing. IP is at the heart of the network layer of the OSI, or internet layer of the TCP/IP model. And then you have routing protocols like EIGRP, OSPF, and ARP, ICMP. ARP kind of operates between layers 2 and 3. ICMP, right, operates at layer 3, it's used for messaging. And then you have transport layer protocols, TCP and UDP. And these are the application layer protocols. HTTP, of course, right here, is the one we use quite a bit when we surf the web, or HTTPS, but close enough. It's similar, right? But there are lots of other ones. Telnet, FTP, SMTP. SMTP is used for email. DNS to look up the IP address from the name. You know, when you and I type in www.cnn.com or globalknowledge.com, right? DNS resolves that name to an IP address, because that's what is used in the IP packets. IP packets don't allow names, they need IP addresses. So DNS translates the names to IP addresses for the IP packets to use, and almost all our data is carried in IP packets, right? So keep that in mind. And then there are all kinds of other protocols as well. IP addresses, by the way, this is talking about IPv4, of course. IP version 4, addressing features, right? It's actually written in dotted decimal like this, but it's actually a 32-bit long number, right? It's 32 bits, 32 ones and zeros. But because humans can't deal with that efficiently, we convert it to dotted decimal notation, right? It has a network portion and a host portion, what they call locally administered, often called the host portion. But each unique interface, each device has to have its own unique IP address, right? So that's what will also help get the data to the right device. And the network portion is what the routers use to get the data to the right network first, right? So that's the idea there. So here it is, right? An IP address that looks like this is broken up into 4 blocks of 8 bits each, called octets. Each octet is converted to decimal and separated by dots, so that's why it's called dotted decimal notation, right? And then at the end of the day, subnetting was introduced because we were not allocating our addresses efficiently. We'd have run out of IP addresses even earlier than we did. And so it also helps make networks more manageable and helps reduce the wastage of addresses. So besides the network and host portion, what they call locally administered earlier, besides the network and host portion, a subnet portion was added right, to the address. Now, it didn't increase the address. The address size remained the same, which means what? We had to steal bits from some one of the other portions to make it the subnet portion. So we stole bits from the host to create a subnet portion that added a third tier. That allowed us to break one larger. So, you know, the purpose of doing that was to break up one larger network into multiple smaller subnets. So what are the questions we ask in order to do this? You say, well, how many broadcast domains or networks do we need? How many host addresses or IP addresses do we need in each network? Right? What's the total address range? What's the potential for growth? Which one's going to grow more? Will we have more subnet? Will we need more subnets later, or will we need larger subnets? Will we need more hosts for subnet? So those are the questions to be asked. And now, subnetting itself, by the way, when I teach that in our classes, I take at least 4 hours to teach it. Yeah? Assuming you don't know the basics, right, then I take at least 4 hours to teach it. And first thing is, what is the purpose of subnetting, right? Why do we need to do it? And then what are the things we need to understand? What are the other things we need to understand before we can actually understand subnetting and do subnetting, so to speak, right? Make calculations of our subnet addresses and whatnot. So the analogy I like to use is it's like the pizza, right? The pizza is the unsliced pizza is the original network, what it is before subnetting. And when we slice the pizza, we basically create a subnet. So now what slice is the equivalent of a subnet. And of course, we won't have just one, we'll have multiple slices. So those become the subnets, right? What are the things we need to know to actually understand subnetting? We need to know binary numbering system, guys. There's no way around it, right? If you really want to understand subnetting, you have to understand binary numbering. It's not that difficult, but you do need to understand it, and you need to be able to convert binary to decimal and vice versa. You need to understand IP address classes, A, B, and C, and the octet boundaries. Right? By octet boundaries, we mean basically where the network portion begins and ends versus the host portion beginning and ending. Right? And then the subnet masks and the rules, how subnet masks work, right? The rules of that and its purpose, significance, etc. So we need to understand that. We need to understand a table, that number of bits and number of hosts. So how many bits do we need to give us how many hosts? Or given so many bits, how many hosts will we get? Or subnets. That table has to be understood. And being able to count the bits. Yeah, that's the reason for understanding binary. Counting the bits in an address. How many network bits do we have? How many subnet bits do we have? How many host bits do we have? All that has to be understood. And of course, the prefix notation, the mask is sometimes written in either dotted decimal notation or prefix notation, or it's called slash something or the other, right? So all that information has to be understood before you even start doing actual subnetting. And that's why I said I take 4 hours to teach it. Most of the time it's spent laying in all this foundation, all this foundational knowledge. And then I say, okay, now if we understand all this, now we're ready to actually do subnetting. But the good news is that if we do all this work diligently, then actual subnetting part is the easy part then. Then it becomes easy. But if we don't understand any part of this well enough, guess what? That's when we get stuck or confused, right? We get the wrong answer sometimes, or we are mistaken, sometimes. So that's the point, and that's what I try to avoid. And I emphasize to students. I actually give them homework when I teach this. I do this one day. A majority of this work is done the previous day, and I give them homework saying, you guys better study all this and practice. And then, once you have done the work yourself, then we will actually do subnetting afterwards, right? It's very critical to understand that as well. So yeah, that's the gist of how I like to do this. Right? And again, I apologize. I've spoken very fast, very quickly. You may have to go back and re-listen to some of this. But what I'd like to do is open it up. Well, first of all, I'd like to share a few jokes with you guys. Take a look. I won't read it out loud. See what you think. See if it makes you laugh or maybe that makes you groan, like one or the other. Okay. So, having said that, I want to open it up to questions. If you have any questions, this would be a good time.
Yeah, thanks, Parag. This was great. So I've been reviewing the question and answers feature, and I don't have anything off the top to address to you. So I think we could kick it off because we've been doing these webinars for a little bit here, and we know some of the questions that come through. One being, can you give a little bit of background on how a student would benefit from attending a full global knowledge session compared to the webinar? I know this is just kind of a taste of it, but can you give a little bit of background on that?
Absolutely, Kevin. Yeah, thanks. So, there's a course corresponding to this particular webinar that covers these concepts. It's called Understanding Networking Fundamentals. That's a course that Global Knowledge has developed. It does not directly lead to a certification, but it goes a long way towards helping in the CompTIA Network Plus certification. It's not enough by itself, but it'll cover a lot of the basic knowledge, and in fact, it'll cover it better, I feel, than the certification might cover itself. Because here's what happens in that particular class: students get all this foundational knowledge: OSI model, switching, routing, subnetting, TCP/IP, right? And they actually don't just get the theoretical knowledge or the conceptual knowledge. They actually get, to apply that knowledge to practical skills by way of labs, right? So students actually get to perform labs in class and see these things actually work in a scenario that's emulating real life, right? With real switches, routers that we provide them access to, and they'll see it. They'll use Wireshark and examine some of the packet details and see even all these things work, which is brilliant. So it's very practical as well. And they also get the benefit of, so they literally will walk away from class with some practical skills that they did not have, with a very sound foundation of all this knowledge, which they may not have had. And the other big benefit, of course, is that they get to ask instructors like me and my colleagues questions in class to clear their doubts, clear their misconceptions, clear any lack of knowledge or gaps that they may have had. And so, and oftentimes most instructors are happy to spend even time after hours to cover some, concepts, even some scenarios that they may bring from their work. Say, look, this is what we've got going on at work. Could you help me understand this better, or what's happening, or how could I do this better? And most instructors are happy to help students with that kind of stuff too. So it's a huge benefit to really lay a strong foundation, and then that helps. By the way, one of the big reasons I love this course is because I would teach more advanced courses like Cisco courses, and even like routing, switching, BGP type courses, and students didn't have this foundational knowledge. Well, they'd be lost when I'm trying to teach them an advanced concept. It's like trying to teach you a master's level course without you having a high school degree, a high school diploma. So this covers that aspect really well, so then students can progress also and do much better at their jobs. So Kevin, I hope that helps.
No, it does. Thank you for sharing that. So looking in the question and answers, I do see a question that popped up. I'm not sure if this has come up for you in the past. An attendee asked, can you teach this to someone who has, and I apologize if I'm mispronounce this, but dyscalculia. So it's basically a math learning disability. So how strong do you need to be in math in order to be proficient in networking?
Very good question. Okay. So not too much. I would say just basic arithmetic, being able to perform basic addition, subtraction, multiplication, division. No additional math is needed. I mean, you don't have, it's just, converting binary to decimal is the biggest part of the math that's needed. And then, calculating 2 to the power of, but I show them how to do that too. So as long as they have some basic ability to learn that and to be able to practice just that part, they shouldn't have any problems. Yeah, so that's what I would say. That's how I would answer that question. Right? There has to be some ability to do basic arithmetic, I would say: addition, subtraction, division, multiplication.
Okay.
But beyond that, not advanced skills of any math is needed.
Very good. So another question came through, and Dr. M. Chandrakala, if I am not understanding your question, please chime in. But he's asking if a meaning for cyber networking. So I don't know if I completely understand if you're asking how does cyber play into the networking role.
Yeah, I think maybe what they meant is cybersecurity is probably what they meant.
Okay.
Yeah, but Yeah, I'm not familiar with the term cyber networking myself, but I think if you're referring to cybersecurity, that's just basically what are the various things we would need to secure our systems, our networks, our devices, all of that. I think that's what would cover that part. And of course, we teach lots of classes for that too. And these days, it's very real, right? It's all of us need to be concerned. It doesn't matter if you are a technical expert or not. All of us have to protect our personal devices and our personal systems, our networks at home, and so on. So we ought to have some basic understanding of at least who we can get help from or how we can achieve that. And of course, if you're a professional at work in security, then you have to know a lot more because these threats are very, very real. Garmin just paid, I think, something in the tune of $10 million for a ransomware attack recently. So, yeah, I hope that helps. If not, please clarify the question. I'd be happy to address it further.
All right, another question that just came through. How do we learn about the networking fundamentals class that you referred to, the syllabus, the time involved, and costs? So that's a great question. So we obviously have our Global Knowledge website. We can give you, the class is actually called Understanding Networking Fundamentals, as Parag has on here. So you can go to our website, search that in our search box, and it will come up with the course outline, the list price of the class, and all the various prerequisites that are needed. However, if you have a Global Knowledge account manager, that individual will be able to speak to this class in more detail, and possibly if your organization has been doing business with us, we could possibly talk to you about various discounts and promotions that are available. But we run this class quite frequently, and definitely with the COVID pandemic, we've been, even before that, we've been running this class in a virtual setting. So Parag, I'm not sure if we touched on that at all, but can you speak to how well classes are run in a virtual setting?
Sure. Thanks, Kevin. That's actually a good point. And by the way, the website also has our schedule. So the schedule will outline, when the next sessions run with a live instructor. Okay. So here's the beauty: even with an online class, you can either do self-paced, which is basically recordings, or you can take the class with a live instructor, where I would, just like this webinar, I would talk live in real time. Right? This is not a recording. This is real. This is live, real time, and you would see the same slides. I would teach you would see in a physical classroom, but this time you see it on your computer screen. You would hear my voice with the audio, and you would even, as I joke, those students who pay extra get to take the class online, so they don't have to deal with me in person, right? They don't have to look at me and see me in person or deal with me in person. So I just joke about it and say they have to pay extra then to take the class online. But no, that's the joke. But yeah, the point is, otherwise you get the same knowledge. Sometimes students, take that class on purpose online because they don't have to waste time trying to commute. If the class is offered like in downtown of a big city like New York or San Francisco or whatnot, it's a pain to get to. But otherwise, it's the same thing. And you do labs online. When students are doing labs, I'm available and very much there to answer any questions. I review the labs before I get them going. I review the labs after I get them going, after they're done. And, we talk about the lessons learned and observations. So if they're having trouble with the labs, I help them out. I'm always available. So yeah, that's how online classes work. Works out really well because we've been teaching online classes way before the pandemic hit also. Right? So, yep, Kevin, I hope that helps.
Yeah, I believe it does. Thanks for sharing that. One question was, again, what is the cost for an online class? And I'm looking that up real quick as we're going here. So the list price in North America, again, it depends, I guess, in what region you're in, but it is $32.95 for a 5-day class. So again, I strongly recommend getting in touch with your Global Knowledge account manager because, again, we have ways to work with you on pricing, but that is the list price that is on the website.
So Kevin,
right.
If I may chime in.
Yeah.
Sorry, Kevin. if I may chime in, right now, Global Knowledge is also offering a variety of different promotions, like annual subscriptions, where you can take, and they have multiple different packages, multiple different levels also. So you can take classes from different groups for an annual subscription, right?
That's right. Yeah, absolutely. And that's a great point. That subscription is called Polaris. And there's, again, various levels, but the level that provides instructor-led training is called Discovery. And if you purchase Discovery for one low cost, you have access for 12 months to a number of different technology classes. So for instance, in this area, if you're interested in networking, you could take the Understanding Networking Fundamentals and then get some practice in, and later on you can take the CompTIA Network Plus certification prep course. So it's a great way to get some skills training, but as well as if you are certification focused, you can get a certification after that, all in 1 year, all for one price. So once you take 2 classes, you basically paid for that price of the subscription.
Yep, cool.
All right, so looking through the questions here, we do have about 10 more minutes, so we have time. We can stay on and answer any questions. One question came through is, can we get a copy of the PowerPoint? So Parag, do you know, I can check with our marketing team, do you know when they get an email of the recording, do they also get access to the PowerPoint?
I don't know if they get access to the PowerPoint specifically. I'm not sure, actually. I apologize myself.
Okay.
But
I'll
they
take
definitely get
an
access to
action
the
item
recording.
there. I'll take an action item there to find that out.
Yeah, they may have shared that with me, but I've forgotten that. I apologize. But definitely, they get access to the recording. So, for all practical purposes, if they take a snapshot or a screenshot, I'll give them the same thing. But yeah, otherwise, this PowerPoint, by the way, is nothing that great. It may help a little bit, but more importantly, so I've made the PowerPoint from slides from our courses, right, mostly, and added the little image of a pizza there, right? But that's basically it. But otherwise, most of these slides come from some of our classes themselves. When you take a class, you don't get the PowerPoints, unfortunately. But yeah, you get access to the recordings though. Still, even the course content. If you take an online class, you'll get access to the recordings for 12 months. So you can go and review that also. That's the other benefit of taking the class, and all the lecture, all the content and stuff like that. Right? So.
All right, another question came through. Can you share more of an explanation of the routing protocols, the slide with all of the FTP, TCP, IP, etc.?
Okay, sure. Dave, all right. I believe that. And Dave, please confirm if this is the slide you're referring to. No, I believe this is.
It is, yes.
Okay, perfect. Thank you. So, yeah, so you want more of an explanation of the routing protocol. See, here's the thing. Routers talk to each other using a language called routing protocols, right? So specifically, the 2 popular routing protocols in our internal networks these days, are EIGRP and OSPF. EIGRP was originally Cisco proprietary. They've kind of made it available publicly, but it's still implemented only mainly by Cisco. No one else really talks EIGRP. OSPF is a standards-based protocol, right? But they are routing protocols. What all do they contain? They help routers learn from each other. Like imagine if you and I live in different parts of the same county or same city, right? So then I'm going to share with you saying, hey, guess what, Dave? I can, through my location, through me, you can get to a Costco, or you can get to a Walmart, or you can get to a movie theater, you can get to the library, right? And here's the cost to get to each of those through me, right? Similarly, you may share that, okay, you can get through me to the local park, or you can get to the local fire station, or you can get to the local, I don't know, some other, the mall, maybe, something like that, right? Or the local Target. You can get to those locations through my neighborhood, through me, And here's your cost. If you want to get to those locations, here's the cost to get to each of those through me if you want. Now, but similarly, we may have somebody else who shares some similar information. Then I will decide whether it's most efficient for me to get to those locations through you or somebody else. And that's the purpose of routing protocols. Routing protocols carry that kind of information, help routers learn about the various paths they can have to get to a destination. And then each router, by the way, decides for itself which is its best path to get to the various destinations. That information is stored in its routing table, only the best path information, even though it may know about lots of other paths. The other paths remain in its back pocket. Best path gets put in the routing table, and the router checks its routing table every time it gets a packet for a given destination and checks whether, how to forward that packet to using the best path towards the respective destination. So the routing protocol is what they talk, what they use to communicate all this information, and really helps build the routing table. That's the ultimate goal, right? Dave, I hope that helps. Okay, I just explained the routing protocol part, right? And again, by the way, that's really what these slides are attempting to do, right? To show you, see the routing. This is the routing this is how it looks it up in the routing table. There are 3 possibilities. So that's the routing process. That's different from the routing protocol. Routing protocols like RIP, OSPF, EIGRP, BGP, etc., figure out what's the best path, and they use the metric to figure out, how good or bad a path is, right? To compare the different paths, right? So yeah, that's what it is.
All right, perfect. So I don't see any additional questions. So we do have just about 6 more minutes remaining. Are there any additional questions you want to add? Please do so now, and we can address those. If not, we do have a bit of wrap up to do, so we can go through that while we wait. So we appreciate everyone's time in joining today's webinar. If you'd like to learn more about the topic that we recommended, we showed you that Understanding Networking Fundamentals class. We talked about the CompTIA Network Plus certification prep course. In addition, if you're working on specific vendor products, we do have courses in Cisco and Juniper and so forth. So please take a look at our catalog or contact your account manager and we can walk you through that. But we want to show our appreciation to you. So as an attendee of today's webinar, you can utilize a 25% off your next Global Knowledge Deliver course, and the promo codes are listed here. So in the US, you type in webinar 25, in Canada, CA webinar 25. But I believe no matter where you're located, if you just type one of those in, you will get the promotion. So the next slide we want to provide you with is some areas. If you have further questions, you can go ahead and hit us up on all of our social media channels. So please do that. In addition, if you have, if you want to look at additional webinars that we've done, again, right now is Cybersecurity Awareness Month, so we are doing a bunch of those type of webinars. So go ahead and take a look at our website. In addition, you'll see white papers, obviously courses, and special offers. So again, one thing that we are doing that is becoming very well received is, again, that subscription-based product called Polaris, where you get 12 months of unlimited access to instructor-led training on various topics. So go ahead and take a look at the website and see if that is of need and of desire for you. So that concludes what I had to cover today. Parag, we appreciate your time and everyone's time for joining the webinar. So this concludes today's webinar. Thanks and have a great rest of your day.
Okay, Kevin, I thank you very much. I actually wanted to also just thank all our participants for joining our webinar. I hope this has been helpful for you, and I just want to remind you, that please, don't skip the foundational information. Whatever means you have to build your foundation, it'll help you enormously in your career, in professionally, making your own life easier, having this foundational knowledge. So do work on it, and then, like I said, good luck and thank you very much. Yeah, we appreciate you guys having attended our webinar. All right, I'm done. Thanks, guys.
All right, thanks. Have a good day.